Hello, Algebra 1B. Today we are going to be on our second day of special cases with multiplying binomials and factoring trinomials. We're going to talk specifically about conjugates and the difference of squares. So what are our learning targets? I can multiply conjugates and understand why the middle term cancels, in quotation marks, resulting in a binomial. Okay, and I want to just mention real quick, this is really special because we already learned many lessons ago that when we multiply binomials, we get a trinomial. And this is a special case because this is the one time that is not going to happen, all right? And then we're going to factor the difference of squares. So basically, we're going to multiply and unmultiply. Okay, so first of all, what are conjugates? Conjugates are basically the same binomial with different signs in the middle. Okay, so for example, if I were to say x plus 3 and x minus 3, you notice it's exactly the same except for the middle piece, the math symbol, in one is a plus and one is a minus, okay? So what's the conjugate of x plus 7? The conjugate is x minus 7. And I just want to point out it's not the opposite, because remember, if it were the opposite, we would change all the signs. The opposite of x plus 7 would be negative x minus 7. We didn't change the x, we just changed the sign in the middle, okay? What's the conjugate of x minus 9? Of course, we're going to do the plus version of that, which is x plus 9. Okay? All right, so I want you to just take a moment, pause the video, okay, using whatever multiplication method you like, whether it's distributive property, whether it's FOIL, or whether it is the box / Punnett square method. I want you to do these 3 multiplication problems and then turn the video back on and rejoin me. Okay, so I'm going to pause right here, and notice I only wrote out my first step. I did the FOIL method, but if you are doing the box or the distributive property, you're going to notice the same thing, hopefully, is that we ended up with a situation in the middle where we would normally combine like terms, where we end up with opposites, okay? And of course, anytime you add opposites, they're going to be 0. So basically, these 2 middle pieces are going to cancel each other out in quotation marks. So we're just going to get x squared minus 9 here. Here, the negative 4x and the plus 4x are going to cancel each other out. We're going to get x squared minus 16. And here again, the minus 5x and the plus 5x are going to cancel each other out, and we're going to get x squared minus 25. So when we multiply conjugates, we get a binomial. And basically, that's because the middle terms are opposites. In other words, when we add them together, we get 0. That's why we said they cancel out. And we're going to put that in quotation marks because that's not like really a mathematically correct thing to say, but I know we say it all the time. Okay, so this is the one and only time that we can multiply binomials and get a binomial. Okay, and it's a very special case. And notice, we always end up with subtraction. All right, we always end up with subtraction. All right, so bottom line here, if we have conjugates and we have something plus something, and then that exact same thing with just subtraction, basically we're going to take that first term, square it, take that second term, square it, and it's going to be subtraction in the middle. Okay. Now, you're welcome to still multiply these out longhand using FOIL, the box, whatever method. You do not have to use the shortcut. But if you know it, it is a time saver, okay? So, x plus 8, x minus 8. They're exactly the same thing, except one is plus, one is minus. I can square the beginning, square the end, put a subtraction sign. So this is going to be x squared minus 64. All right. Here we have another example, x plus 10, x minus 10, exactly the same, except one is plus, one is minus. I can go ahead, x squared, 10 squared is 100, subtraction sign in the middle. Now, sometimes we have a little bit more complicated, and we have an actual coefficient, so 3x plus 7, 3x minus 7. All right, so remember, we're going to square the first term, and we're going to square the second term, And so this is really what we end up doing. Now, if you can do this math in your head, you don't have to write this stuff down, but I just wanted you to see 3x, the entire thing raised to the second power, is going to be 9x squared. 7 to the second power is 49. There we go. Okay, so you have to remember to square both pieces of this. It's not going to be 3x squared, it's going to be 9x squared. All right, 6x plus 11, 6x minus 11. 6x raised to the second power is 36x squared. 11 squared is 121, so 36x squared minus 121. When we get these answers, they have a special name, which is a difference of squares. And remember, difference means subtraction. So if I were to say, like, what's the difference of x and 3, you would say x minus 3. So we've been using this word difference often. So when we have two perfect squares with a subtraction sign in the middle, we have what is called a difference of squares. Okay, I'm going to see if I have time to get some more work in here. All right, so now, factoring a difference of squares. Okay, so that's multiplying conjugates. You create a difference of squares, which is a binomial. If you happen to bump into a difference of squares on a factoring worksheet, we want to know how to handle that, okay? And this one is a little bit trickier, so I'm going to show you kind of something that might help you if you don't like the shortcut, okay? So a difference of squares is a binomial with perfect squares on each end and a subtraction sign in the middle, okay? So basically, perfect square, subtraction sign, okay? Remember, when you multiply conjugates, the middle terms cancel each other, okay? So when you see something like this, x squared minus 25, when you see a binomial, and I ask you to factor a binomial, first thing you want to look at is it a perfect square, and is it subtraction? Keynote, if it's not subtraction, you cannot do this, okay? So what I want to think about is, what's the square root of the first piece? What's the square root of the second piece? Because remember, this is 5 squared. So x squared minus 25 very quickly factors into x plus 5 and x minus 5. Okay, now remember I said that if you're like not a shortcut kind of person, you're like, I just want to do this the old way and I'm feeling overwhelmed because this is too much to try to memorize right before test, keep in mind that we could write this way, okay? Since there's no x term, we can add that placeholder, okay? So we could also write as x squared plus 0x minus 25. Okay, and then that way you could go back to factoring the other way where you would think of two parentheses. All right, I have subtraction at the end, so I know I need an x plus and an x minus. And I need two numbers that multiply to be negative 25 that add to be 0, so they're going to have to be opposites, and that would tell me x plus 5 and x minus 5. Okay, so this is something you can do if this part doesn't make sense to you, okay? Or if you ever get stuck on a test or quiz, your mind goes blank because the stress is coming, over you. Okay, let's take a look at a little bit more difficult example. All right, once again, I have a binomial. I said to factor it, so before you start, hyperventilating and getting panicky, think, hey, wait a minute, is this a perfect square? Remember, 49 is a perfect square, and so is x, and we just kind of put them together. Perfect square, because that's 9 squared. And the subtraction, okay? Really, really important. I just want to highlight this. Subtraction in the middle is something that has to be there because you can't factor it if it's not. All right, so I break it down. Where did this term come from? Where did this term come from? And I can go ahead and put each of those in. So it's going to be 7x plus 9, 7x minus 9. And once again, if you're confused, let's also, okay, we could go ahead and put a 0 placeholder in if that makes more sense. 49x squared plus 0x minus 81. Now, here's where this gets to be difficult, okay? If you're not understanding your perfect squares, and you try to do this with the AC method, right, and you end up multiplying 49 times negative 81, I don't even know what that is. The reason this can be a little bit tricky if you don't know the shortcut is you could end up with a really painful math problem, okay? But keep in mind that whatever you get, right, when you multiply the a times c and get whatever this number happens to be, I don't have my calculator with me, you're going to have opposites in the middle because you do have to have that middle term cancel. So keep in mind, it's always going to be a plus and minus of the same thing. So if you get stuck and you're trying to find this zero, that should help you try to figure it out. Okay? All right, so let's try a couple. Perfect square subtraction sign. What's the square root of 110? I have a positive and a negative of the both same thing. Easy peasy. Perfect square subtraction sign. What's the square root of 81? It's 9. X plus 9. X minus 9. Binomial, perfect square subtraction sign. All right. What's the square root of 64? It's 8. 8 plus 8. X minus 8. Okay, so tell you what, why don't you try these three real quick? Oh, maybe not. Okay. So let me keep talking then, because I just realized when I looked at them that maybe we shouldn't have you do them yet. All right. Now, perfect square subtraction sign. I want to show you a caution. What's the square root of 36x squared? That's going to be 6x. Square root here is going to be 4. But I'm going to go ahead and put this in. Do you see that 6x plus 4 and 6x minus 4, those are not factored all the way? Okay, so not done. So I would say probably would be a better plan, instead of doing this and then trying to factor it, which you could do, okay, because again, we can factor these out. Let's look for a common factor first. All right, so I see 36 and 16 are both even. I know they divide by 2, but let's see if I can come up with a bigger number. I see they divide by 4. So let me try that. 36x squared minus 16, divide them both by 4. So I'm going to get, I'm running out of room, 4 times 9x squared minus 4. Okay, now I have smaller perfect squares. Okay. So let's go ahead and perfect square subtraction sign. I can change this into 4 times 3x plus 2 and 3x minus 2. And the reason this is a better method, because typically when students try to factor this at this point and get GCFs out, they get a little confused because you'll pull a 2 out of this one, you'll pull a 2 out of this one, you'll have 2 and 2 2's, which then turn into 4. It just gets complicated. Okay. All right. This does not appear to be a difference of squares because 75 is not a perfect square. 3x squared is not a perfect square. However, I notice they both divide by 3. And I get 3 and x squared minus 25. Now that I've pulled out that common factor, I do have a difference of squares. Perfect square subtraction sign. This is going to be 3 times x plus 5 and x minus 5. Okay. So remember, we need to look for common factors. And always better if you can pull those out up front, right? Look for those first. Okay. And again, if you don't find them up front, you can do it at the end. All right, take a look here. I have an x cubed. Remember, I can't factor anything with an x cubed. I have an x at the end. Let's divide out that x on both of these. And I have x and x squared minus 64. Perfect square subtraction sign. I have a difference of squares. I can change that into x times x plus 8 and x minus 8. There we go. All right, last thing. These cannot be factored. And you encountered that on a puzzle worksheet we did recently. Okay. This is not x plus 3 squared. That is not the case, okay? These cannot be factored. And it's tricky because you think they can, but they can't. So when you see perfect square addition, you are done. Done. Nothing you can do. All right, so that's it. That was a long video. Thanks for hanging in there, and I will see you back in class.